A linear function is given. Complete parts A through D. The linear function is h of x equals 1/4 x minus 3. Determine the slope and the y-intercept of the function. This linear function is written in slope-intercept form, y equals mx plus b. So we can determine the slope by looking at the coefficient of the x, and the y-intercept by this constant on the end. So this linear function has a slope of 1/4 with a y-intercept at the ordered pair 0, -3. We want to use this slope and y-intercept to graph the linear function. To do that, we'll plot the y-intercept at 0, -3, and then use the slope to get to a second point on the line. The slope is the rise over run. So we're going to rise from that y-intercept 1 unit and run 4 units. So we're going to go vertically 1 unit and horizontally 4. And that gets me a second point on the line, and we can connect those 2 points with a straight line. Then we want to determine the average rate of change of the function. Because we're working with a linear function, the average rate of change is constant. And the average rate of change is the slope of the line. So the average rate of change for this linear function is 1/4. Now using that average rate of change, or the slope, we can determine whether the linear function is increasing, decreasing, or constant. For any linear function that is increasing, it will have a positive slope, decreasing will have a negative slope, and constant will have a slope of 0. So this function has a slope that is positive, and so the function is increasing. We can also use visual inspection by looking at this graph of the linear equation. You can see that as we look from left to right, the y values are rising or increasing. The linear function is given. Complete parts A through D. So our linear function is h of x equals 1/4 x minus 4. In part A, we want to determine the slope and the y-intercept. So we know that this function is in slope-intercept form, y equals mx plus b. So the slope is 1/4, and the y-intercept is -4. Then we're going to use the slope and the y-intercept to graph the linear function. So we have a slope of -4 and a y-intercept of -4, and the slope is 1/4, so I'm going to rise 1 and run 4, and connect those 2 points with a straight line. Then we want to determine the average rate of change of the function. So there's a theorem that says if you have a linear function, then the average rate of change is the slope. So the average rate of change is the slope, which is 1/4. Then it says to determine whether the linear function is increasing, decreasing, or constant. If we look at this graph, if we trace it from left to right, the y values are increasing. But we can also tell that this function is increasing based on the value of the slope. Whenever the slope is positive, we have an increasing function. Whenever the slope is negative, you have decreasing function. And if the slope is 0, you have a constant function. So this is something that works for linear functions. So for this example, we have our function h of x increasing. For the quadratic function f of x equals x squared minus 6x minus 7, we want to find the orientation, vertex, axis of symmetry, intercepts, domain and range, and also graph the parabola. And we're going to use completing the square to find the vertex. So we're going to start off by understanding what is the general form of a quadratic function. The general form is f of x equals ax squared plus bx plus c. And to determine the orientation of the parabola or quadratic function, all we need to know is the value of a. A is the coefficient on the x squared term. For our example, the coefficient of our x squared term will be a 1 since no coefficient is listed. With a being a positive value, being greater than 0, we know that this graph, the parabola, will be oriented up. We'll have a parabola that opens up that looks like this. So anytime we have the value of a being positive, the orientation will be up. Then we want to find the vertex, and we're going to find the vertex by completing the square. So we're going to start with our function f of x equals x squared minus 6x minus 7, and we're going to start by factoring out this leading coefficient from the x squared term. In this example, because we have a coefficient of 1, we don't have to do this step, but if there is a coefficient there, you want to factor it out of both the x terms. And you're going to leave that constant alone, and you're only going to group your x terms together. Then the completing the square process begins. You're going to find the magic number, and you're going to find the magic number by starting off with the coefficient of the x term, which is -6 in this example. So I'll do this on the side over here. We start with that -6, and we're going to divide it by 2 and then square it. So -6 divided by 2 is -3, and -3 squared is 9. And that's the magic number that we want to add inside the parentheses. So we're going to add a 9 inside the parentheses, and we need to balance our function by doing the opposite of what we've just done. Now we've added 9 inside the parentheses. We need to consider if there is any number in front of this parenthesis as well. So that would be a 1. 1 times 9 is 9. So to balance the equation, I have to do the opposite of that, which is to subtract 9. So since I've added 9, I need to subtract 9. So this will give me x squared minus 6x plus 9 minus 16. Now I'll be able to factor what's inside the parentheses, and it'll become a perfect square trinomial. So this will factor to become x minus 3 squared minus 16. So what we've done is we've taken our function from general form into the vertex form, and when it's in the vertex form, you can write down what the vertex is. It will be hk. So the vertex for this example is 3, -16. Now there's an alternative way to find the vertex, and that's using a vertex formula. And the vertex formula is that the x-coordinate of the vertex is -b over 2a. And for our function, a would be 1, and b would be -6, and c is -7. So negative b, that's negative 6 over 2 times a, which is 1, would give a positive 6 in the numerator, 2 in the denominator, and that's 3. So the x-coordinate of our vertex is 3. We can find the y-coordinate, k, by substituting that value of h into our function. This would give 3 squared minus 6 times 3 minus 7, 9 minus 18 minus 7, that's negative 9 minus 7, which is negative 16. So you can see that we got the same vertex that we got using completing the square. So we found the orientation and the vertex. Now we want to find the axis of symmetry. And for a parabola, if you draw a vertical line that passes through the vertex, you get a line, this line of symmetry. Around this vertical line, the parabola is symmetric on both sides. So what we need to know is the vertex in order to state what the axis of symmetry is. So the axis of symmetry will be a vertical line. The equation of vertical lines is x equals, and we'll use the x-coordinate of the vertex to state what that vertical line is. So the vertical line, x equals 3, is the axis of symmetry for this function. We also want to know the intercepts. Let's start by finding the x-intercept. So if we have the function, which is f of x equals x squared minus 6x minus 7, and we want to find the intercepts, we'll find the x-intercept by letting y equal 0. This is written in function notation, so y is f of x, and that would give the equation 0 equals x squared minus 6x minus 7. Let's try to solve this by factoring. X times x is x squared. 7 times 1 would give 7, and if I have a minus on the 7 and a plus on the 1, we've factored our quadratic function. I can set each one of these factors equal to 0 to get x equals 7 and x equals 1 for our x-intercepts. And then we want to find a y-intercept. So we start with our function f of x equals x squared minus 6x minus 7. To find a y-intercept, we'll let x equal 0. So I'm substituting a 0 into the function, which gives 0 squared minus 6 times 0 minus 7, and that is negative 7. So we have our y-intercept at negative 7. So I think we're ready to graph this function and find the domain and range. So to graph the function, I'll plot the y-intercept and not the y-intercept, the vertex, and it goes off my screen a little bit. So since that went off my screen, I got a different grid, and now I can plot that vertex at 3, negative 16. We have x-intercepts at 7, and I think I made a mistake here. This is x plus 1, so this x-intercept should be negative 1. And then we have a y-intercept at negative 7. And keeping in mind that this point here is the vertex, and the vertex will be a turning point for the function, creating a little minimum value in this case. And that gives us the graph of our parabola. And now it's also easy to see what the domain is. The domain will be all real numbers, negative infinity to infinity. And the range, you can see, will start, the range is the y values. The range will start at the vertex, which has a y coordinate of negative 16, and go to infinity. So our range is negative 16 to infinity. Finally, we want to state where this quadratic function is increasing and decreasing. So if we take a look at our picture, we're going to trace our graph going from left to right. So from left to right, you can see that this portion of the graph have y values that are decreasing, and this portion of the graph have y values that are increasing. And you can see that that dividing point is at the vertex. And we're going to use the x coordinate of the vertex to separate these two intervals. So we have a function that is decreasing on the interval from negative infinity to 3, and increasing on the interval from 3 to infinity. Now I've written this with parentheses. There are different definitions that involve increasing and decreasing, and sometimes the definition includes the endpoint and sometimes it doesn't. So pay attention to the wording in your textbook to decide whether you want to include these endpoints or not. So you might need to have brackets so that the endpoint of that interval is included. Determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find the value. We're given the function f of x equals negative 2x squared plus 8x minus 2. This quadratic function is written in general form. General form is f of x equals ax squared plus bx plus c. We can determine whether this quadratic function has a minimum or maximum value based on the value of a. A is negative 2 for this example. And this value of a is going to tell us the orientation of the parabola. We have a value of a that is negative or less than 0, and that means that our parabola will be oriented down. And when a parabola is oriented down, that creates a maximum value at the vertex. Now, we can find the maximum value by calculating the vertex using the vertex formula. So we usually state that the vertex is the ordered pair HK, and we have a formula for the x-coordinate of the vertex, and that's negative b over 2a. So you can see that the value of a is the coefficient of the x squared term, the value of b is the coefficient of the x term, and then the value of c is the constant. So let's calculate the x-coordinate of the vertex. We have b is 8, so negative 8 in the numerator, and a is negative 2, so we have 2 times negative 2 in the denominator. This is negative 8 over negative 4, which is a positive 2. Now the maximum value is actually the y-coordinate, so we need to calculate the y-coordinate of k, and we can get that y-coordinate by substituting h into our function. So we're going to substitute h being 2 into the function to get that maximum value. We have negative 2 times 2 squared plus 8 times 2 minus 2. We're going to follow order of operations, applying the exponent first. 2 squared is 4. and negative 2 times 4 is negative 8. Negative 8 plus 16 is positive 8, and 8 minus 2 is 6. So this function has a maximum value of 6. Diana has available 440 yards of fencing and wishes to enclose a rectangular area. Express the area of the rectangle as a function of the width of the rectangle. For what value of W is the area the largest? What is the maximum area? So, since Diana wants to enclose a rectangular area, a rectangle has a length and a width, and the area of the rectangle can be calculated by length times width. Now, it seems like we're almost there, but we want to find the area as a function of width. Right now, we have area as a function of length and width. So what we need to do is we need to use this 440 yards to try to get rid of this variable of length in our function. So the 440 yards is the fencing, and the fencing will go around that rectangular region. And that fencing refers to the perimeter. So the perimeter of a rectangle is 2 times the length plus 2 times the width. So we're going to use all of that 440 yards of fencing. So I'll substitute 440 in for perimeter. And now I can solve this equation for the length so that I can get rid of that variable in the equation. So I'm going to solve for length by subtracting 2w on both sides. That gives me 2l equals 440 minus 2w. I'll divide both sides by 2, and that gives me a length of 220 minus w. So now we're going to be able to answer that part A. We said that the area of the rectangle is length times width, and now that I know that the length is 220 minus the width, I can substitute that in. And simplify a little bit, I've got 220w minus w squared. So now you can see that I have an area function whose only variable is w, which is width. So that is the answer to part A. And in part B, we want to find what value of w is the largest area. So this is kind of an optimization question, finding the largest in this case, but optimization is also finding the smallest in some cases. So what we know about this example is that our function a equals, I'm going to rearrange it a little bit, negative w squared plus 220w is a quadratic. And the graph of a quadratic is a parabola. This particular parabola has a negative leading coefficient, so it's going to be a down-facing parabola. So this is going to be the graph of the area function, a quadratic, and the highest area is going to occur at the vertex. So if we want to find the largest area, we need to find out what the value of that vertex is. We have a formula for calculating the vertex. We can find h by calculating negative b over 2a. That's negative 220 divided by 2 times negative 1. It's negative 220 divided by negative 2, and that's 110. Then we find the y part of the vertex by substituting that 110 into the area function. It's going to be negative 110 squared plus 220 times 110. Okay, so we're going to type that in our calculator. Negative 110 squared plus 220 times 110. I get 12,100. Now just to pay attention, we've got two numbers here for the h and for the k, but we want to make sure we know what those numbers mean. Typically in an ordered pair, HK, the H stands for the X and the K stands for the Y. In our equation, we don't have X and Y. We have A for the Y part and W for the X part. So for the width, we get 110, that would be yards, and that is our H. And for the area, we get 12,100. That would be yards, square yards, and that's our K. So to answer the question, this is for part B and C, for what value of W is the area the largest? The area will be the largest when the width is 110 yards. And then for part C, what is the maximum area, or the largest area? The largest area will be 12,100 square yards. Thank you for checking out my videos. Have a great day.